Hello everyone, today we're going to present a case study on BIM implemented project in Hong Kong. This is the outline of our project. I'll first give you a brief introduction about the background of the case we selected, and then we'll talk about the scope of BIM, the BIM implementation in this case, the limitation and challenges of BIM adoption in this case, so as the suggestion for improvement, and end with a conclusion. We selected Sojino Estate as the topic of our focus study. Sojino Estate is a public rental housing which the year of intake is 2015 and have a total of 18 blocks. The reason why we selected Sojino Estate as our focus study topic is because Housing Authority has mentioned that 5D BIM have been applied to the construction of the Anderson Road Sites A and B, which includes the first and the second phase of the construction in 2013, while 5D BIM also applied on the construction of Wet Market and Site B and the Footbridge, which were finished and open to use in 2017. Now let's move on and talk about the scope of BIM implementation in Sojino Estate. What is BIM? Building Information Modeling is not only a series of software, but also a process of creating a building information model with graphical and non-graphical forms, which would get more detail with progress of the construction. The adoption of BIM allows a project to be designed, planned, built, and managed in a more efficient way. So now let's move on and talk about what is 3D BIM. 3D BIM is the most common type of BIM, which is create a three-dimensional building models. As we can see that it is the Sojino Estate 3D model provided by the Housing Authority 2017. And the function included in 3D BIM are as follow. The adoption of 3D BIM allows a better analysis of the feasibility of the proposed project. 4D BIM is basically the 3D BIM plus the concept of time and scheduling. The function included are as follow. By adopting 4D BIM, it can increase the project's feasibility and the efficiency by sequencing it logically. 5D BIM is basically 4D BIM plus the concept of cost tracking and analyze. Function of 5D BIM are as follow. The adoption of 5D BIM allows the project developer to analyze whether a project are financially feasible or not. 5D BIM is adopted during the construction of the Sojino Estate. It is adopted during the construction of the Anderson Road Site A and B. It is used in site planning and work sequencing stage to improve the productivity and quality of work. On the other hand, 5D BIM is also applied of the construction of the wet market in order to provide the best remedial solution and optimizing the planned work schedule to catch up a 3 months delay. 6D BIM is basically 5D BIM plus the concept of sustainable development. The function of 6D BIM are as follow. By adopting 6D BIM, it can allow developer to comply energy requirement standards with satisfaction. Last but not least, 7D BIM is basically 6D BIM plus the concept of facility management. Common 7D BIM's functions are included as follow. The adoption of 7D BIM allows developer or operators to monitor systems condition and arrange on-time repairment.
This session will introduce BIM application through Sojino case. In this case, BIM adoption helped overcome the list 7 challenges. The first one is geographical complexity. Sojino Estate is located on a hillside which is dominated by slopes with 90-meter difference between the highest and lowest working platform. The project is quite extensive because it requires to maintain the accessibility and workability within the hilly estate, resulting in complexity of the distribution of components of the project. BIM model assists the project team to have a clear view and optimization of design on the degree of integration between the estate and its environment, such as existing roads, the natural river, the elevated highway nearby, by the simulation of both project model and the environment. The second challenge is complex and unique design of entrance footbridge. The developer aimed to construct the bridge as a landmark. The bridge adopted a dome-shaped design with 51-meter height and 78-meter span. The bridge also adopted incremental launching method due to environmental concern. The construction sequence of the bridge is therefore connected so closely that it is inseparable. The 4D simulation and 3D model of BIM technology therefore facilitate the analysis and clarity of project team on the construction process of the bridge. The 4D simulations have been modified for numerous times for the inseparable temporary and permanent component and improve the construction process continuously each time. The third challenge is limited site area for crane and transportation. The site area is limited due to existing shopping mall and a residential building. Limited site area resulted in restrained crane location. BIM helped in simulating the movement of tower crane to find a most suitable adjustment. The only access route for material transport is highway, which has height limit. Besides, the entrance for truck into the site will pass through a covered bus station, which also limits the shape of prefabricated material. BIM simulation therefore helped the project team to design the process and requirement of material transport to reduce risk.
Another BIM function applied in this project is quantity takeoff. In phase 1 of the project, contractor employed label with HA construction electronic measurement standard on building components, which allow quantity surveyor to directly extract price data from existing database in the model. Manual adjustments were done by QS to minimize discrepancy with traditional quantity takeoff from 10% to 5%. BIM also contributed as medium for immediate change in design detail based on actual situation. Example can be found in bridge pier in estate footbridge, as BIM is used for 3D simulation to arrange space reservation for later tie-down bolts installation, and output 2D drawing for on-site communication. At the same time, as you can see in the figure, the rebar system was quite complex for the pier, so BIM was also used for clash detection between tie-down bolts spacing and rebar system to narrow down and select a suitable composition. Size constraints makes it difficult to do on-site measurement and coordination for modular installation. Therefore, BIM was also applied for calculating a 3D coordination of modular that's used to locate modular by observation on coordination sticker. BIM and component head tracking was used for recording the construction process to carry out comparison on planned and actual schedule and cost later on. Returned records is also used for checking on-site installation accuracy. Remedial adjustment and further review were performed repeatedly. Hence, the overall error is less than 0.1% for the construction. From this case, several impacts of BIM is shown. First, project accuracy is improved by continuously updating coordination, geo-information, cost, and schedule throughout the entire project. Efficiency was also improved in stages. Quantity takeoff, project variation, and reviewing work were sped up by fast track of data sharing between parties. On the other hand, there must be some downside for the application. Information stored in BIM was fragmented. Absence of linkage between information in different areas makes it difficult and time-consuming to find. Also, as BIM software are generally developed overseas, it's incapable to support local standards like Hong Kong standard method of measurement for. Even in the BIM standard by CIC published later on, there is no specific requirement for modeler to compile with on cost estimation. Further, as contractor and developer comes from China and Hong Kong respectively, if the contractor and developer is applying different BIM standard, for example Chinese standard and Hong Kong standard, conflict in elementary quantity rate and quantity takeoff difference might be dealt and cause argument.
Before we go to the recommendation and conclusion, let's have a look on the simulation video provided by the Housing Authority. Last but not least, let's move on to talk about recommendations. As 4D and 5D BIM is getting more and more popular, problems induced from the non-standardization of BIM model is become more apparent and more serious. In order to increase the BIM efficiency, standard approach of modeling (SAM) must be adopted to solve the non-standardization of BIM model. With the adoption of SAM, it can improve cross-communication between parties and standardizing model to link with other software. Despite the fact that SAM is not yet well developed, HKHA has already promoted SAM with standard model and building component. With constantly updated BIM version and SAM, facilitating interlink between parties and software is possible and improve the efficiency of BIM. This is our reference list, and thank you for your attention.